Alright, so we're talking about application of proportions. We've been doing a lot of proportions. Now we're going to apply it to certain sections, geometry and other things like that. So first, let's talk about our learning target. It is I can use proportions to solve problems involving geometric figures and to find the measure of similar figures. Alright, definition time. So the first thing we're going to define is what similar means, and I'm talking more about a geometric term of similar. When we're talking about similar, we're talking about figures that have the exact same shape, but not the same size. Okay, so these two figures right down here, they're similar figures. They don't have the same size, but they have the same shape. Okay, now corresponding sides and angles are proportional sides in two similar shapes that have equal measures. So we're taking a look here. AB, the corresponding side of that would be DE. BC would be EF, and AC would be DF. Okay, and just the same goes with those sides. We're talking about the angles too. Measure of angle A is equal to the measure of angle D. Measure of angle B is equal to the measure of angle E. Measure of angle C is equal to the measure of angle F. Okay, so that's what we're talking about when we're talking about similar figures as well as corresponding sides and angles. Okay, that'll help us with this next example. Example 1 asks us to find the value of x in the diagram, okay? And we know that x is right here in SU, line SU. And so we're gonna write down the corresponding sides that we have. So we know we have MN, line MN. The corresponding side of that is line ST. We're going to set that equal to, we're building the proportion MP, line MP, over SU. So we're just building a proportion based on corresponding sides. Okay, so now let's go ahead and plug in those numbers right here. MN is 6 centimeters. And ST is 4 centimeters, and that should be equal to, we're talking about corresponding things, that should be equal to 14 centimeters, which is the distance of MP, over X centimeters, which is the distance that we don't know and the distance that we're trying to find out. So at this point, we have a proportion now. All we have to do is just use our golf club rule. 6 times X is just 6X. Is equal to 4 times 14. Okay, first let's multiply 4 times 14, that's 56. And then we just have to divide by 6 on both sides. And we end up getting x is equal to, you know what, I don't know what 56 divided by 6 is on my head, so I'm going to say, hi friend, 56 divided by 6 is 9.3 with the repeating decimal. So, the value of SU, the distance of that is 9.3 centimeters. Alright, example 2. Example 2 says that a flagpole casts a shadow 75 feet long. At the same time, a 6-foot tall man casts a shadow that is 9 feet long. We need to write and solve the proportion to find the height of the flagpole. And I put in here hashtag keep the proportion, okay? So here's how you can remember how to do this. We all know hashtag, right? Twitter, okay? Here's your hashtag. That's an ugly looking hashtag, but you know I'm a terrible drawer. What that means is that we have to keep things organized. So we're going to keep the flagpole, everything about the flagpole, we're going to keep that on this line here. Everything about that man, that dude, we're going to keep over on this line. The height of the object is going to be along this line, and then the length of the shadow is going to be on this line right here. So we're keeping everything in line. Okay, we made a little hashtag right here. Okay, so let's go ahead and fill in those things. We're going to set up a proportion by doing line equals line. Okay, this is a division, and we're setting up that proportion. Now we know that this first, the top right here, we need to have the flagpole, talking about the flagpole and the height of the flagpole. Well, we don't know the height of the flagpole. That's what we're trying to figure out. So that'll be x. And then this bottom section, the denominator here, is going to be the dude's height. We know he's 6 feet tall. So this is going to be 6 feet down here. Is equal to the flagpole's length of shadow, which is 75 feet long. And the dude's length of shadow is 9 feet long. So we've now created our proportion here using our hashtag keep the proportion, right? We're going to go ahead and do our golf club rule. 9 times x is 9x. 6 times 75. I don't know what that is, so I'm going to have to get my friend. 6 times 75. Hi, friend. 6 times 75 is 450. So 9x is equal to 450. Divide by 9 on both sides. And we end up getting x is equal to 45 divided by 9 is 5. So x equals 50. Therefore, the flagpole is 50 feet tall. Yay! All right, peace.